Okay, now we're going to be talking about limits at infinity. So think about this. As you're headed off towards positive infinity or negative infinity, what are the y values? Is the graph going up? Is the graph going down? We're looking at what the y's are doing as the x's are headed out this way. What are the y values doing? So when you have a polynomial, so that's any x to the positive integer, that's x to the fifth, that's a polynomial, right? You know that from Algebra 1, probably before that. So because there's a negative sign in front that's attached to the x squared, that just means that the graph has been reflected. So instead of it going in the positive direction, remember positive x to the odd, on the right side is going up, on the left side is going down. If it's a negative x to the odd, the left side, the negative side will be going up, the right side. So that this is that case. And as we head towards positive infinity, what are the y values doing? Well, the y values are headed towards negative infinity. All right, so now I'm going to cover this one up. So now we have a positive x to the fifth, and we're also headed towards positive infinity. So as we are headed in this direction, where are those y values headed? To positive infinity. Okay, now we have the second situation where we have the limit as x approaches infinity. In the numerator, the exponent is lower than the exponent in the denominator. So that's x to the first, that's x to the second. Remember what I said, whenever you have special situation, only when we're talking about limits at infinity, x to the lower over x to the higher, what you're doing is the graph is headed towards a horizontal asymptote where y is equal to 0. So for whatever's going on with that graph, and I don't know what that graph is doing exactly, but there's this asymptote, and from both sides, maybe on this side the graph is headed this way, and maybe on this side the graph is headed this way, right? But both sides, that height is a height. So if this is -1, this is -2, -3, 1, 2, 3, well, this height is a height of 0. So anytime you have x to the lower over x to the higher, when you're talking about limits at infinity, the answer is automatically 0. So for the second one, you have x to the first over x squared. And you could even kind of do that highlight that you know that this is lower than this, and then your answer is automatically that. Okay, here's the third specific situation. So even though this looks pretty confusing because of the radical, notice the square root of x squared is x. Well, in the denominator, the square root of x squared is equal to x. So that's x over x to the first over x to the first. So remember what we have here. When you have the limit, when the highest exponent in the numerator is the same as the highest exponent in the denominator, you're headed towards a horizontal asymptote of the coefficient attached to those x's. So the ratio of a to b. So notice what we have here. If you were to simplify this, well, the square root of 2 is just 2. Square root of x squared is x. But down here, the square root of 4 is 2. The square root of x squared is x. So now look at, here is our a, and here is our b. So you're approaching a height, horizontal asymptote at root 2 over 2. I'll just get that out of the way. So whenever you have x to the same over x to the same, whatever coefficients are attached to those x's, that's what the height will be. That's where the limit is headed, towards that horizontal asymptote, right? So root 2 over 2, so that's 1.41 about over 2, right? So not quite 1. So if this is 1 right there, somewhere down here there's a horizontal asymptote that it's headed towards. All right, I'm going to cover that up. Well, look at what we have here. An x squared over an x squared, those are the same. That invisible coefficient right there. The negative sign, always give it to the numerator. So that becomes -1 over that invisible one, which is the height of -1. And that's all the work that you would have to show me. Okay, now we have, I don't know if they're the most difficult, but anyway, I don't think that they are, but they might be. So when you have x to the higher over x to the lower on limits at infinity, all you're going to worry about is the slant and vertical asymptotes. And then pretty soon the graph draws itself. And then if you're headed towards positive infinity, what are the y values doing? If you're headed towards negative infinity, what are those y values doing? So let's do this right here. So we have an x cubed over x squared, and there's that invisible 1 right there attached. So now you have to figure out the vertical asymptotes. It's a little bit complex. Let's see if I wrote it down. So if you want to know how to figure that out, just set, since you know that +2 has to zero that out, just put 4x squared equal to +2. Divide both sides by 4. So now you get 1/2. Take the square root. Well, we can't have a denominator √2, so you multiply top and bottom. √2 times √2 is 2. √1 is 1. 1 times √2 is √2. So you get positive and negative. √2 is where the vertical asymptotes will be. So just like that, negative √2 over 2 and positive √2 over 2. All right? And then I'm just going to kind of eyeball where I think that slope might be. But to be fair, the slant, it doesn't matter really what if the slant asymptote would have looked like this? Maybe it would have looked like this. That doesn't really matter because you don't care about any of the middle stuff of the graph. All you're caring about what's happening at the very end of the graph. So as we're headed towards positive infinity, what is happening up here? As we're headed towards negative infinity, what would be happening with the y values? So if you look right here, we're headed towards negative infinity. And I'm going to draw so here are the asymptotes, and I'm going to draw this graph now. So you get really close to those asymptotes, and you don't care about this piece because that's where x is equal to negative √2 over 2. What you care about is where is this y value headed the closer you get to negative infinity. It is headed towards negative infinity. All right, let me see if I can. All right. So that slope is going to be a slope of 1. And this is tricky. Because that's a plus sign and that's squared, this one will not have a vertical asymptote. It's only going to have a slant. It's probably not even, no, it will have a slant asymptote. You'd have to do long division, but the slant asymptote should be at a height of that. So somewhere you can look at the asymptote then. If you don't have vertical asymptotes what you're going to be doing almost is looking at, so that's going to be an x to the fourth over x squared essentially simplifies to an x squared, and somewhere in there right would look something like that. There would be a slant asymptote in there. I don't know exactly what that graph would look like. However, what I do know, actually, hold on just, okay. So I'm going to hold back for just a second, or pull back up a little bit. Notice there will be slant asymptotes only when it's one. So if this is x cubed over x squared, or if this is x squared over x to the first, so when I paused, I went and looked at Desmos just to make sure I was going to end up drawing the graph correctly, and I was, except for the reason there's no slant asymptote is because when it's 2 degrees higher or more, you just tell me what that graph would look like. That's a positive x squared. So that graph is going to, and I don't know exactly where it will be on here, but that graph is going to be doing this somewhere. And it might be a little bit flatter because there's that x to the fourth right there. So usually x to the fourths are a little bit flatter, right? Well, we're headed towards negative infinity. And if we're headed towards negative infinity, what are the y values doing? The y values are headed towards positive infinity. Sorry, it's a little bit confusing on that one. When it's the values between the exponents are 2 or more, you just quickly do x to the fourth over x squared. Well, that leaves x squared, and then sketch that graph to figure out what the y values are doing. All right, that's it for this one.